Hello, this is Dan. This is part 2 of my USB smartphone charger quest. As you can see here, I've gathered up several wall warts or USB AC adapters. I've got 4, 8, 9 adapters here. And what I've done, I've qualified all of these adapters. I've set up my programmable DC load for 1 amp, and I've plugged each one of these in, and I've written down at 1 amp what their output voltage is. So I'm going to take my trusty Oneplus cable that works well, plug that into my test connector here, and we plug it in, and as we can see here, 4.93 volts at 1 amp. I'll just do a couple of these. Here's my Oneplus adapter, 4.97 volts, 1 amp. Here's a Samsung adapter I have from probably an older smartphone. And this one we can see actually has a problem at 1 amp. It cannot supply 1 amp, that's why this voltage is cycling. I previously measured this, I took it down to 0.5 amp and it was stable. If we look at the fine print on this adapter, it says it's only rated for 0.7 amps. So if you had a smartphone that was trying to draw an amp, which most do, this would not work so well, or it would be very slow. So an interesting adapter I came across was this Monoprice adapter I bought a little while ago. Plug that in, and we can see that it's 4.73 volts at 1 amp. Curious. So that's roughly 0.3 of a volt low. That could cause some problems with our phone, because our phone is going to see that low voltage and is going to start scaling back how much current it will pull. So I'm going to roll all these off to the side. I'm going to bring in my phone. The phone is right now roughly at a 75% state of charge. It's turned off. This is a handy little adapter that measures current, voltage, and time. Print's pretty small and the contrast isn't that great, so you're probably not going to be able to read it. You'll have to trust me. This says, that's not where I wanted to have it plugged in. I'm going to plug it into the phone. I've measured this little measurement dongle against my other equipment, and it's pretty close. It's within maybe 1/10 of a volt. Closer than that, actually. Okay, so this adapter with this cable, 5.06 volts, 0.96 amps. This adapter with this cable, .9 volts. Let's wait for a second for that display to turn off. Here we go, 0.96 amps. So pretty good combination. Grab that Monoprice that we were worried about. have to say that, you know, typically haven't had problems with monoprice gear. This could be just a defective unit, who knows. Okay, so it's currently supplying 4.63 volts. Let's wait for just a second for things to settle down. Okay, display's off. 4.74 volts, 0.26 amps, 0.3 amps. So this is roughly a third of the power that we have seen previously. So that adapter with this good cable could take a long time to charge, maybe roughly 3 times as long to charge. Okay, let's take one of our poorer performing cables that we saw in the part 1 of this test. Plug it into this guy, plug it into there. Whoops, wrong cable. Let's remove him so he's out of the shot. Plug in. Okay, phone's sensing that something's plugged in. Let's wait for it to stabilize for just a second. Wait for the display to go off. It's going to be poor. Here we go. 4.74 volts, 0.11 amps. So there you go. With a adapter that's measuring about 0.3 of a volt low, this cable that was seeing roughly a 0.65 volt voltage drop. The combination of these two dramatically scales back the charger in this phone. 0.11 amps. We saw over 1 amp previously with the right combination. Prediction is, with this setup, this phone will take 10 times longer to charge. Pretty crazy. So you're not dreaming that sometimes your phone seems to take longer to charge when you're just randomly plugging in into whatever cables and adapters you have laying around. 10x the difference. Pretty curious. Okay, there you go. That's what I wanted to talk about.